what you should be thinking is 1 over sine, or you just find the sine of pi over 2 and take its reciprocal. You take its... Oh, we have to scan cards. I almost forgot to scan them. All right, so we're doing the reciprocal of 1 over sine of pi over 2. Well, pi over 2 is 1, and the reciprocal of 1 is 1. In other words, this would be 1 over 1, which would just be the big uno. ¿Qué pasa? You could, yeah. Or you could have tried it and then did it. Yeah. Our second one is secant is negative 3 pi over 2. If you would add 2 pi to that, you come up with pi over 2. So we would do the cosine of negative 3 pi over 2, which would be 1 over 0 over 1, which would turn into 1 over 0, which is undefined. But as Safa said, we did that yesterday. The only new one we really did was tangent of 7 pi over 6. First of all, what quadrant is 7 pi over 6? What quadrant is 7 pi over 6, Jacob?
3.
Quadrant 3. How'd you know that? Did you just have it memorized?
Yes.
You had it just memorized? What trick could you use if you don't have memory? It's awesome if you just know. Nora?
It's 1 over, so it's like the denominator is 1 over the denominator.
Yeah,
So
yeah.
like the numbers are larger.
So our numerator is just 1 bigger than our denominator, so it's in quadrant 3. So tangent is all students take, tangent's going to be positive. Whatever answer I get is going to be positive. Why I say that is because you could have used a reference angle. You could have did 7 pi over 6 minus 2 pi, which is the same thing as 7 pi over 6, minus 6 pi over 6, which equals pi over 6, which would be your first tick mark. And your first tick mark with tangent, since it's positive, it'd be positive square root of 3 over 3. Because guess what you don't have on tests? Your unit circle. But here's the thing. All I have to know is quadrant 1. I just have to keep that memorized from year to year. That's the only quadrant I have to know. And I actually can get every single angle from just quadrant 1. I don't have to keep going around the unit circle and finding out where 7 pi over 6 is on my unit circle. Yeah?
Why would it be 6 pi over 6? 7 pi over 6 minus 6 pi over 6.
Oh, I'm sorry. I did it wrong. I was just going through that too quick. You are 100% correct. I should have did 7 pi over 6 minus pi.
Oh.
Because we are in quadrant... We are in quadrant 4 here, right? So I want to get this measure of this angle here. Currently, I have all of that. So I want to subtract away basically 180 degrees or pi, so I'm just left with this little angle.
So on the next test, we're not going to have to do the unit circle.
Well, you can always fill in a unit circle. I'm just saying, like on the final, I don't grade your unit circle. I give you one, and if you want to fill it all in, awesome. But it can save you time if you know how to use reference angles to just do this stuff in your head. So time-wise, it's easy to use reference angles. But if you don't get it and you don't want to use it, you can always just fill in the whole unit circle. Just a reminder, though, you will keep using the unit circle next year in calculus. But and you never have to take it in college.
That's a lie.
Then you don't have to worry about it. What was that?
Is that a lie?
Yeah. Most people end up having to take calculus. There's very few degrees that don't require you taking calculus anymore. And a lot of colleges at least make you take a math. So let's say you just need a Precalc, and you graduate with Precalc and you clap out of it kind of thing. They still kind of make you take at least one of their math courses. Algebra 1. Pre-algebra, I know this. All right. Yeah. All right. However you splice it, it should be square root of 3 over 3, but this should have been one that you could have had memorized. because you are required to know all of your tangent values around the outside. Because the test we take next Wednesday, if you're figuring out all your tangent values for a unit circle, it's going to take way too long to take the test and you're running out of time. So you need to have your tangent values memorized. Which brings me to a good point. You should still be, every once in a while, testing yourself on the unit circle. Like I said, any day I want to, I can just throw a quiz at you for the unit circle. And you are required to know your sine, your cosine, and your tangent values. You're required to know all of those. All right, any questions on any one of these three? So the correct answer would have been C, square root of 3 over 3. All right, we'll go through the lesson and then we'll go over questions, barring any time. All right, so the basic graph of a tangent graph. We're going to plot very specific points. We're going to plot negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. So we're going to go ahead and take out our unit circles to make sure we get these values correct. You should have a unit circle with all your tangent values on. For those of you that got your bell work question wrong, you might want to make sure you know where your tangent values are and how to read that. Can someone give me the tangent value of 0 degrees? What is the tangent value of 0 degrees? Yeah,
0.
It's 0. That's a nice easy one. What's the tangent value of pi over 4? Can someone give me the tangent value of pi over 4? It is that middle one. Yeah. Is it? No. You're telling me. That would mean that negative pi over 4 would be in quadrant 4. Tangent is negative in quadrant 4, so that would be negative 1. Yeah.
Well, if you get pi over 4, it's negative pi over 4, it would just be the negative version.
It wouldn't just be the negative, because it'd be like... So, where's my stick of latitude? Pi over 4 is this angle here.
Yeah.
The angle negative pi over 4 would be the same angle, but in the negative direction. So it would actually be 7 pi over 4 if you added 2 pi to it, but is this angle right here.
Okay.
So for tangent, it would be negative. But if I asked you for the cosine of negative pi over 4, it would actually be square root of 2 over 2. All right, those don't tell you exactly if it's negative or positive, it just tells you what quadrant you're in. Yeah. All right, then what's the tangent of pi over 2? What's the tangent of pi over 2? Yeah.
It's undefined.
It's undefined? Oh, that's mean. Which must mean that negative pi over 2 is negative undefined. No, just undefined. Why is undefined important? Now remember with secant and cosecant, we had to draw vertical asymptotes where it's undefined. The same thing is going to happen with tangent. You are going to do a negative asymptote at negative pi over 2. So we'll do a vertical asymptote because it's undefined there. And then we'll do a vertical asymptote at pi over 2. Then we're just going to plot these in between points. So negative pi over 4 is negative 1. Well, negative pi over 4 is halfway between these. So this is my negative pi over 4. This is my pi over 4. At negative pi over 4, we were at negative 1. At 0, we were at 0. And at pi over 4, we were at 1. Now, here's what this graph looks like. It looks kind of like a snake of sorts, I guess. That helps you remember it. Snake graph. And this is one full cycle of your tangent graph. Because what's going to happen next, if we went further, remember this is just an additional cycle. If I ask you to graph the tangent. What was that?
Is it a sideways sign?
Is it a sideways sign?
Like, oh,
Nope, that would be another cycle. And it would just keep repeating over and over and over. But this is, if I ask you to graph tangent of x, this is all you need to graph. Just this one with a vertical asymptote and a vertical asymptote. That's all you need to graph. I just want you to know it's just going to keep repeating in this direction, and it'll keep repeating in this opposite direction as well. So it just keeps going over and over and over like that. And that's important because I'm going to ask for the domain in this one. In your homework, you really don't have to, but in this one, we have to name the domain. Just for practice, just because I know people really struggle with domain and range, we're going to start throwing at you earlier than waiting till next semester. All right, domain. Domain is how far left to how far right your graph goes. So you're going to be using x values. Well, this graph goes forever in the negative direction. The problem is all of these undefined. So if you were going to go negative infinity, you'd have to find the first place as a vertical line and the next place as a vertical line if you wanted to use that standard form. We aren't going to do that. We're going to list the domain by saying what values x can't be. Rather than listing all the values x can be, we're going to list all the values that x can't be. And rather than going, well, it can't be negative pi over 2, can't be pi over 2, can't be 3 pi over 2, can't be, we're just going to put one equation to this. And it's going to be k pi plus, there's a couple ways you can do this, but I'm going to stick with the pi over 2. In other words, what I'm saying is at pi over 2 is the vertical asymptote. 1 pi away from that is another vertical asymptote. 1 pi away from that is another vertical asymptote. So I'm just adding intervals of pi. 1 pi, 2 pi, 3 pi. And if you make this a -1, what I'm saying is there's a vertical asymptote at pi over 2. But if I put a negative pi, there's going to be a vertical asymptote here. So what this is specifically saying is there's a vertical asymptote at pi over 2. And then every other vertical asymptote is exactly pi units away from that original. That is the easiest way to list your domain on something like this. Can someone give me the range of this? How low to how high does this graph go? What is the lowest point to the highest point? Mary? Say that again? So you're implying that if I put my finger on this graph, I need to stop at -1. There's nothing between -1 and 1. Is there a break in this graph? Is there a break in the graph, I guess? Remember when we had, so this is not on this graph, this is just additional. We had the U's. This is what I mean by a break, where you go up and you have to stop here, and there's no graph here, and then it starts up here. Does that happen on here? Is there a break between the graph? No. So are there values between -1 and 1? No, I'm just saying, does the graph exist between -1 and 1? So in this distance here, is there a solid line still there? Yeah. So there is no break in this graph. It would actually be from -infinity all the way to infinity. Mary, if you put your finger on this graph, all the way down at -infinity, if you could reach -infinity, you could touch the bottom of this graph. And you just keep your finger on this graph, and if you never have to lift it up all the way to infinity, there is no break or anything. There's no place to put a union in. It is just -infinity to infinity. So with cosine and sine, where we had the U shapes, if I put my finger way down here and I did this, I have to lift it up and put it down there. That's why we have that union. Does that make more sense? Cool. All right, then the last thing is the period. The period is going to be how long one of these little snake guys are. And that is pi units. Because it's negative pi over 2 to pi over 2, so our period is going to be pi. Pi. Okay. Cotangent's a little bit different because it's undefined or in different locations. If you're looking at a unit circle that has your tangent values on it, you'll see at 0 and pi, your tangent value is 0. Take a look if you don't believe me. Your tangent value at 0 and pi is 0, which means your cotangent is undefined at those locations. So since my tangent at 0 degrees is 0, the cotangent would be undefined. And at pi, it'd be undefined. All right, so we're going to go between 0 and pi. So I'm going to go ahead and put my vertical asymptotes at 0 and pi. All right, the cotangent of pi over 4. Does anyone know the cotangent of pi over 4? Just find your tangent value, take the reciprocal, and go from there. Tasha? 1. And I'll give you the cotangent of pi over 2 is 0. Can someone give me the cotangent value of 3 pi over 4? Find your tangent value and flip it. Yeah. It is -1. All right, so our cotangent graph, we're looking at pi over 4, which is right here. We're looking at 3 pi over 4, which is here. At pi over 4, we're at 1. At pi over 2, we're at 0. And at 3 pi over 4, we're at -1. So it's going to look almost identical. It's just going to go in different directions and have different vertical asymptotes. Once again, this would repeat over and over and over and over again. Which leads us to our domain. Once again, we're going to list our domain as values of x that don't exist on our domain. So we're basically listing where are all our vertical asymptotes. Well, our vertical asymptotes are every pi units. This is 0 pi. This is 1 pi. At 2 pi, there'd be 1. At 3 pi, there'd be 1. So this would just be k times pi. The range, once again, would be from -infinity to infinity, and the period would still be pi. Know these. Hint, there could be a quiz on all these graphs tomorrow. So there could be, it would just be a basic one. It would just say, the quiz, if I had one tomorrow, would just say, do a secant graph, a cosecant graph, just no shifts or anything. Just can you graph cosecant of x? Can you graph secant of x? Can you graph tangent of x? Can you graph cotangent of x? That would be the quiz tomorrow if I gave one, because it'd be, I always like quizzes to be super short because I don't want them to take up half the class. All right, so if there's a quiz, you just have to draw that black line and the vertical asymptotes, that one, and know how to do cosecant and secant. All right, that's all that quiz would be on if I gave one tomorrow. All right, cotangent and tangent transformations. Dropped an eyeball. These can be hard because they're very different than sine and cosine and secant and cosecant. Did I say that one? When you're graphing cotangent and tangent, the period will be pi over b. But in fact, we don't worry about this that much. When you graph tangent and cotangent, you need to know these two equations. When you graph tangent, you're going to set everything that's in here equal to negative pi over 2. Then you're going to set everything here equal to pi over 2, and that's going to give you two vertical asymptotes. Those are going to give you your two vertical asymptotes. And then you just draw a normal tangent. When we graph these, we don't worry about the amplitude. The only thing we worry about that 2 is that it's positive. So when you're graphing these, the only thing you're worried about the amplitude is whether it's positive or negative. Once again, the amplitude, the only thing you're worried about is it positive or negative? Then we just put it up one. I think this is easier if we actually do an example. So let's go through an example. Once again, your amplitude. All we care about is that it's positive. All we care about is that 2 is positive. Did I put a note on mine? So I basically put, don't worry about amplitude just if it's positive or negative. So we're just looking to make sure that's positive. For positive or negative. So we're just deciding if it's flipped. Then I also care that's going to go up 1. All right, for tangent values, you set everything in there equal to negative pi over 2, and then you set it equal to pi over 2. So we're going to have two different things. We're going to have 2x plus pi over 2 equals negative pi over 2. And we're going to set it to x plus pi over 2 equals a positive pi over 2. This will handle the period, and it will handle your shift left or right, all in one step. So I'm just going to set those two things equal to see where our vertical... We don't add them together. That's an and sign, sorry. That is my nifty and symbol. So we're going to solve both of these. We're going to go ahead and solve both of these. So I'm just going to distribute that 2. We're going to have 2x plus pi equals negative pi over 2. Then I'm going to subtract pi from both sides. So we're going to have 2x equals negative pi over 2. Well, I'm supposed to subtract pi, but I think it's easier to just write pi as 2 pi over 2. But that is just subtracting pi from both sides. That will give me 2x equals, well, negative pi over 2 minus 2 pi over 2 is negative 3 pi over 2. Then we divide both sides by 2. We end up with x equals negative 3 pi over 4. That is one of my vertical asymptotes. Now we just solve the other side, just like we did that side. So we'll have 2x plus pi equals pi over 2. I think I'm going to build the wall because I'm getting pretty close. I zoomed in a little too far. So then we'll have 2x equals pi over 2. Subtract pi from both sides. That's actually minus 2 pi over 2. That'll be 2x equals a negative pi over 2. Divide both sides by 2, and you have x equals negative pi over 4. Those are your two vertical asymptotes. Mary?
Just curious, is it a coincidence that when you add those together, you get negative?
Well, no. Yeah, that's a coincidence. Well, it's not quite a coincidence. It's just saying that the period is pi still. It didn't change that period. All right, so we're going to go ahead and graph this by picking those things. So we have negative pi over 4. Then I would have negative 2 pi over 4. Then I would have negative 3 pi over 4. Well, one of my vertical asymptotes is at negative 3 pi over 4, so we'll go ahead and put a dashed line there. Then we'll put a dashed line at negative pi over 4. And a normal tangent graph goes up on the right side, down on the left side, but we do need to go up 1 unit. So we're going to go up 1 unit, and that will be my final graph. So one more time, when we're dealing with cotangent or tangent, we don't really care about the amplitude. We just want to make sure if it's negative, you have to flip everything. If it's negative, everything would be flipped. If it was negative, everything would be flipped. But since it's positive, I don't care about it. We tackle the period and the phase shift by setting it equal to these two things. And then we just have to go up or down. All right, one more graph together. This one's going to be cotangent. I don't care about that 1/2. All I care about is it's positive. So that means no flip. It's positive, so I'm not going to flip anything. There's no up or down. So we're going to go straight to pulling out this whole 3 times x minus pi. So we'll have 3 times x minus pi. When you deal with cotangent, your undefineds are at 0 and pi in the original equation. So that is why you set your equation to 0 and pi. You're just setting it equal to your vertical asymptotes. So we're going to set 3 times x minus pi equal to 0. And we're going to do 3 times quantity x minus pi equals pi. Those are my original vertical asymptotes. I'm just going to shift them to see where they're going to go. All right, so that's going to give me 3x minus 3 pi equals 0, which would be 3x equals 3 pi. Divide both sides by 3 and you'll have x equals pi. So we have a vertical asymptote at pi. We have a vertical asymptote at pi. Let's do the next one. We have 3x minus 3 pi equals pi. Add 3 pi to both sides. You'll have 3x equals 4 pi. And divide both sides by 3 and you'll have x equals 4 pi over 3. All right, so we have to get the 4 pi over 3. So what I'm going to do is maybe pi of 3's, like I'm close. That'd be too much, but we'll try it. Pi over 3, 2 pi over 3, 3 pi over 3 would just be pi. And then finally we'd have 4 pi over 3. So I need a vertical asymptote at pi. I guess I smushed it together a little bit too much. It's okay. And our cotangent graph starts high and goes low. That's a terrible one. Let's do that. That's better. It's going to look something like that. And honestly, yeah, Bree.
For the formula,
Yeah.
it's x plus 3, but can you just do whatever's in the parentheses?
Yes. Are you saying because in the formula it has
X plus 3.
it has like x plus c, right?
Yeah, that's
Yep. But you take whatever. Remember that's just generic. So really this is x plus a negative pi, but it's kind of redundant to write that. So just whatever's here, just plug it in and set it equal to the original vertical asymptotes. Yep. Don't overthink these. Yeah, Mary.
Sorry, so do you just choose which equation you use?
You don't just get to. If it's cotangent, you have to use equal 0 and pi.
I mean, like, there's 3 times x plus 3 equals 0.
Questions do we have from the homework? Nora.
Okay, the last one, number 5 on page 50, page 54.
Okay, number 5.
It's like, I don't know where the period was, and I don't know how to talk about it.
Okay. Can you read number 5 to me? Because I believe that's one that I had different than you guys.
Y equals secant quantity 3x plus pi over 4 plus quantity plus 4.
Oh, okay. So assuming the first thing you might have done is you maybe rewrote this as secant, and you'd probably pull out a 3.
Yeah.
So we'd have 3 times x plus, and that would be pi over 4 divided by 3, which would be pi over 12. Plus 4? So So we're good there? All right, then let me draw a really crappy XY. That's always nice when you come up. All right, then let's find the period really quick. So the period would be 2 pi over my b value, correct?
Yes.
So that'd be 2 pi over 3. So I would just count out maybe 4 spaces. 1, 2, 3, 4. Do my 2 pi over 3. That's a terrible 3. That's a better 3. Divide that by 2 and you'd have pi over 3. Divide that in half and you'd have pi over 6. Multiply that by 3 and you have 3 pi over 6, which is pi over 2. Am I okay so far?
Oh, yeah, okay.
All right. Then we're going to have maybe 1, 2, 3, 4, 5, 6, because I just see something that's going to happen. Because this needs to go up 4. The amplitude is still 1, correct?
Yes.
And since we're dealing with cosecant, I'm going to graph the cosine. Now, cosine usually starts at 1, but now we're actually going to go up 4 units. So our sinusoidal axis would actually be on this 4. And it's okay if I do the shift left also at 1. Tell me if I went too far, I guess.
No, you're good.
All right, because this would be, I guess, negative pi over 12. All right, so cosine starts up, and then it goes down at my next, so this would be positive pi over 12. Then it would go down 1. Then it would come back up to 0. And then it would go up to 1. So this would be my cosine. Are you okay with that?
Yeah.
You sure? Yeah? Are you just mostly doing yours right now?
Yeah.
Okay.
I get that. Yes, I got it. Okay.
So you should have a vertical asymptote at negative pi over 12. And you should have a vertical asymptote there. And then our actual graph would look something like that. Cool. Mark, did that make sense? I know you had questions on that one too. Other questions from the homework? Looked like that was the big one that stuck people. You okay, Bree?
No.
Do you have questions on this one? Or is it the homework you're working on right now?
The homework.
Oh, okay, that's fine. You just learned it.